Greetings of the day. Welcome to the course on Operations Research Technique. Students, in previous lecture, we have seen the concept of Fulkerson's rule in network management, and in Fulkerson's rule, what we are going to do is we number the events as per logic from left to right and top to bottom. If you recall my previous lecture, in that what I did is we have drawn one particular small network like this, consisting of activities like this and this, ending with this. Now see here, what I have said in my last lecture was I want to number the events. And numbering of the events or node, this is event. So logic is left to right, top to bottom. We can say top to bottom as like this also. I can also say top to bottom. As a general principle, starting number to that event which has only outgoing, last number to that event which has only incoming activities. So count the number of events: 1, 2, 3, 4, 5. Starting 1, last 5. Our logic is left to right, top to bottom. So activities emerging from already numbered event. We know that physically activity is emerging. Assume that it is not emerging while numbering next event. To understand this concept of suppose it is not emerging, what I have to do? I have to put my palm like this. Now, though this is emerging, I am assuming it is not emerging. I want to number this event. Now, with this condition, what you can see is this particular event is having only outgoing arrow, and therefore that must be numbered in sequence of earlier number. We have numbered 1. With this logic, we will number this as 2. Then this is over. Same thing over here. This is having no incoming, only outgoing. Left to right, top to bottom, 2, 3. Remaining 4. Again for 4, what you have to do? Assuming it has no outgoing, like that. Here, if I assume this one outgoing as not having actual outgoing, still it is having one incoming arrow. But since the only event to be numbered is this left one, we have represented it with 4. So now this particular event is numbered, and I can write the activities of this particular project as 1, 2, 1, 3, 2, 4, 3, 4, 4, 5 and 3, 5, like that. So this is something to mention what the Fulkerson's rule states. Now let's move ahead. These activities play very important role in network management. Different types of representation of activities is there. This is, I have given these statements for your reference. I will explain this all concept, mentioned concept, with the help of diagram. What we have to keep in mind is, suppose I am saying activity I j like that. So this particular part, arrowhead, is activity, and this is start of activity. J is end of activity. But in real sense, I is starting event, J is end event. I is starting event, J is end event. Got it? I is starting event, J is end event. Now, see, very important. As mentioned in previous slide, this is activity. I j, and I have written this, but it is not visible. This one is starting event, and this one is completion, or other name is end event. Starting event and completion or end event. Now this particular diagram represents activity node relationship. This particular diagram represents activity node relationship. Try to understand the same concept through this. In my last lecture, if you recall, I have explained this as, this is head of activity and this is tail of activity. If you recall my last lecture, see, activities are to be represented by straight line arrow. These are straight line arrow. But if somebody is representing activity like this or like this is a wrong concept in operations research or network management. Activity means it is a straight line arrow, maybe inclined one, but it is straight in forward direction. Activity is never represented by curves like this. Now, what this figure says, let's understand. This particular is node, this is activity, this is activity, further activity, other activity. This write-up is not visible, therefore I am again writing on it. And this is again activity, this is one more activity, and this is node, and this is, I will draw by some other see. Now let's understand the concept. This is I have mentioned tail, head. Same is explained on this diagram. For this activity, this is tail of arrow, tail of the arrow. This one is arrow. This is arrow. Arrow has this tail and this head. So same is written over here. This portion is marked as tail of arrow. This is written as tail of arrow, and this is written as head of arrow. Same what I have shown over here. Node is represented as tail. Node is represented as event. Now what to understand? For the time being, this is activity, this is activity. This particular project ends at this point. This is end event. This is end event. Now focus your attention here. Dummy activity, which I have joined. Say this is this representation is similar, except it is continuous arrow. It is dash arrow. I am using the word dash arrow, and dash arrow is used to represent dummy activity. So new term has coined, dummy. This particular term dummy we have used in transportation, we have used in assignment models also, which is not in existence, but to move ahead, to move further, we need to consider that it don't have any effect on the solution of the problem. In the similar way, here we will consider the importance of dummy activity in a project only to show the relationship between interdependent activities, but that dummy activity, since it won't exist, what I am saying, dummy activity, since it is fictitious, means it won't exist, will not consume any time and resource. We have studied in earlier lecture, activity consume time as well as resource. But now keep in your mind, if it is dummy activity, time for dummy activity 0, resource consume for dummy activity nil, because physically it is not in existence. So what for it is then in calculation, it is then analysis? Only to satisfy precedence relationship, that's all. The existence of dummy activity in network model is only to satisfy the precedence relationship of various activities of the project. Keep this aspect in mind, very important aspect. So activity represented by straight line arrow, activity consume time as well as activity consume resources. Activity consume time as well as resources. But if it is dummy activity, it won't consume time, it won't consume resource. It is only to indicate precedence relationship, that's all. Moving ahead, very important. Under the category of activities, predecessor activity, second is successor activity, and third, which just we have discussed, is dummy activity. Predecessor, successor. Suppose, focus your attention here. Suppose I draw part of network like this. This is what I have drawn, is a part of network where I have shown activity C and activity D. To understand the concept of predecessor and successor activity, students, for D, C is predecessor. For D, C is predecessor. For C, D is successor. Got it? For C, D is successor. For D, C is predecessor. These two terms are clear now. We have seen dummy activity. It only shows dependency. Now, how to interpret this? This event, I will write here. What is this? This is event. This event will be assumed completed when this C is completed, and this D can start. Very important aspect. Activity D can start only when activity C is completed, and when activity C is completed, in turn event is completed, activity can start only this event is completed. So unless and until predecessor activity is completed, successor activity cannot start. The terminating point for predecessor activity will be ending in the event. If predecessor activity is completed, that event is completed. Once the event is completed, from that successor activity can start. One aspect. Now this dummy, as many times mentioned, does not consume either any resource or time. Activity which does not consume resource or time is called as dummy activity. Activity which does not consume resource or time is called as dummy activity. Then what is that? It is added only to establish the given precedence relationship. This I am repeatedly iterating. The significance of dummy activity in network models is only to satisfy the given precedence relationship. That's all. So time consumption for dummy activity is 0, resource consumption for dummy activity is 0 because it does not exist. Let's move ahead. Now, this is very important. Unless and until you are not through with this network logic, understanding will be a problem. So what I have written, rules, which is logic for network construction. Students, here activity, I want to show activity A. So activity A is shown like this. Two events a arrow, and above that arrow a name of activity, that is activity A. Now this is important. B must follow A. B must follow A means B is following A. So naturally this A is predecessor and B is successor. B is predecessor, B is successor, A is predecessor. So previous activity is predecessor, following activity is successor. Along with this, here I will give other logic to this. This can be again explained as, very important, B greater than A, or same can be written as A less than B. This is one way, this is second way, this is third way to give the same information, or one may write B succeeds A, fourth way. Fifth way, A precedes B. This particular information, sorry, not this, this is again, if you are not clear, what I'll do, suppose I want to indicate this second information. This is B must follow A. This is one way of giving the data. Second way of giving the same data is, I have written B greater than A. Third way of giving the same data is write A less than B. Fourth one can write B succeeds A. One can write A precedes B. All these five sentences, including these, means this. That's what I wanted to emphasize. This is what is called as logical relationship, and this is logical sign. Same thing, same diagram explained by 5 ways. You must understand this. Keep this in mind. Similarly, if the concept is B and C follows A. Now look here, students, B and C must follow A, must follow A. To those to whom we follow will be predecessor, and which follows will be successor. Simple. B and C follows A. Who follows? B and C. So B and C ahead of A successor, follows, trailing, predecessor. Means unless and until A is complete, B and C cannot start. So first you have to complete A, end a node, then start B and C. So see here, same is done over here. A, then complete, then start B and C. The meaning is we can start B and C simultaneously after A is finished. Got it? Other. C must follow. Now my words, must follow A and B, follow A and B. To whom follow? A and B. Who follows? C. One who follows? Successor. To whom follow? Predecessor. A and B, predecessor. C, successor. So unless and until both C and D predecessor merge at one node, merge at one event, further activity C cannot start. So A and B predecessor and C successor. A and B predecessor, say successor. So how the logic can be written? Again in the same fashion, C greater than AB, one way. Other is A and B less than C, other way. C, same, C precedes, succeeds. If I want to write in the form of preceding, I have to write A, B precedes C, or C succeeds A and B. Again same thing by 5 ways. Now this is very important aspect. Suppose I want to show that C must follow A and D, C must follow A and D. C must follow A and D, means C is greater than A and B, and D must follow A and B. D must follow A and B. This is C must follow A, so C must follow A, this is one sentence, and D must follow, this is other sentence. So students, what we have to do? We have to represent this particular situation in the diagram where C follows A but D follows A and B both. Suppose we give this in other direction. We want to show dependency of C. This particular diagram is showing dependency of C only on A, but D is showing dependency of A and B both. Out of this is very important, C depends only on A, but D depends only on D depends on both A and B. Now here some students which usually commit mistake. What they do? Instead of giving this dotted, they give it straight line. When you draw straight line, means you are saying that it is the real activity, and we know real activity consume time as well as resource. Where from you will get resources for this activity? Where from you will get time for this activity? How you will name this activity? You are unnecessarily creating problem yourself by joining this A and this node by solid arrow. That is wrong. What you have to do? You have to draw it by only dotted. Means this is now dummy. Dummy of what? Dummy of A. This is dummy of A. This is only giving relationship. What I have explained in my earlier deliberation. Dummy activity do not consume time and resource, but it helps to resolve precedence relationship. See, precedence relationship is D depends on A and B. Now this is activity D. If I don't draw this, it is only D depends on B. If I draw dummy line, it indicates D depends on A and B both. D depends on A and B. A and B, this dummy is representing this activity A for sake of precedence relationship. So we must be very sure in understanding for logics of network construction. Let's move ahead. Now, the dummy activity is also referred as many times redundant, idle, but most commonly used terminology is dummy activity. Now this is very important slide, very important slide. See, this is one way I have shown that you are not supposed to draw arrow by curve. Here he has drawn arrow by curve. This is wrong. But suppose one is representing this same by parallel activity as, very important, try to understand. This is activity A, this is event number 1, this is event number 2, and this is D. Now you come across a situation and you draw diagram like this. What you did, from same node to parallel activity. Again I will repeat, from same node, that is same node means 1, to same node, that is 2 parallel activities. This is not possible. Never attempt network like this. Very important. No two activities starting from same node ending to same node can run in parallel. Important statement. No two activities starting from and ending in same node can run in parallel. Never draw. This is wrong network. Of course, this is also wrong network. Try to, instead of giving straight, he has tried to give curve. But curve arrow is not permitted at all. Suppose we can't avoid this situation, then what to do? How to proceed? This is the requirement of the problem. That further activity depends on these two activities. So the solution is there. Solve this concept by using aspect of dummy activity. Use dummy activity here. So you can use dummy activity either for B or for C, depending on the scenario pertaining to that situation of the project. You can have dummy activity with B or dummy activity with C. How? See here, in this particular case, I have shown the dummy activity with C. Again, this is activity A, B and C. This is not possible. So what I did is 1. Let it go ahead. This is activity B. I want C also. I want C also to end at 2. So this is 2. But D depends on B and C both. D depends on B and C both. This is not permitted. So what we did is give dummy between 2 and 3. This is dummy, so it won't consume any time, it won't consume any resource. Only it is indicating relationship of D with B and C. That's all. Got it? Clear? Suppose I want to show relationship of dummy with B. Same logic. A 1. Now dummy with B, C natural as it is. So if you want to show, depending on the situation, dummy with B, so have a dotted line from 2 to 3, which is dummy, and get 3 event completed, from which you can start activity D. So again I am saying this is very, very important concept of handling of dummy activities. But what is our observation when we say that dummy activity does not consume any time and resources? It is observed through experience. Student unnecessarily put lot many dummy activities in the network where they are not required at all. A network, simple network where no dummy is required, I have seen students putting 3, 4, 5 dummy activities unnecessarily in the network, making it again more complicated. So you have to be very careful when to use dummy. So dummy to be used only when we cannot show the situation of 2 parallel activities starting from same event, ending in same event. In that situation, use dummy to represent either of the activity by dotted line. Again, I will explain this concept in numerical. Now, critical path analysis. When we talk of any project or network, we have to have this important analysis referred as critical path. Now, before that, let's understand what do you mean by critical path. We have used the term earlier, we have used the term critical and non-critical activity. So when we will do calculation for the network, after analysis we will get various paths of the network, and of the various paths of the network, some path will be critical path and the activities on critical path will be referred as critical activity. Rest of the activities of entire project other than activities on critical path will be considered as non-critical activity. And as I have said in my previous lecture, in ICU, critical care unit, we monitor those patients than normal patients. In the same way, in any project, the activities which are critical are to be monitored to the great extent, because delay in critical activity is not at all permitted. Critical activities must be completed within stipulated time, whatsoever the case is. Got it? So, the objective of critical path analysis is to estimate the total project duration and assign starting and finishing times to all activities involved in the project. This helps to check actual progress against scheduled duration of the project. Now we have seen that planning, scheduling and control, there you have some targets for different activities. So what is the difference of scheduled with actual execution? That is possible in this analysis. The duration of activities may be uniquely determined in case of CPM, or may involve 3 time estimates in case of PERT. Yes, uniquely means only one time, that we have seen, only one time, and here we have seen 3 time estimates. If you recall again, so these 3 time estimates were TO, TM and TP. So how to distinguish PERT problem and CPM problem from understanding point of view is, any PERT problem will be having 3 time estimates for activities. Any CPM problem will be having only one unique single time for the activities, because we have seen in difference that PERT is deterministic, whereas PERT is probabilistic, whereas CPM is deterministic. In deterministic we are sure that this is the only time required, but in probabilistic, which is the case in PERT, we are having 3 different time estimates. Now consider the following notations for the purpose of calculating. This is now understanding from mathematical analysis point of view. So here these 2 coin terminologies are very important. One is EI and other is LI. Now first thing, keep in mind this concept I, J, activity. Students, keep this in mind. Always your mind must focus. If it is given activity 1 to 2, activity 3 to 4, 3 is I, 4 is J, 1 to 2, 1 is I, J is 2, like that. So activity with basis Ij, I is first event, J is second event, ending event. First is starting event, second is ending event, in between is activity. And now when I give this notation, so here generally what we write, activity name is written over arrow, head arrow, and activity time is written below. For example, suppose I want to give this same like this, activity A, and if I write 5, 1, 2. So students, meaning of this is that this activity is named as A, which consumes 5 units of time, maybe days, maybe weeks. I have not mentioned. I am saying 5 units of time. I have written name of activity above arrow. I have written activity time below arrow, starting, end. This is not the confirmed rule. Some textbooks, they also give it as like this, 1, 2, they write it A/5. So first is name of activity followed by time. We will follow this pattern. Got it? So now what we will do, for this mathematical background, to understand the details of all these things which are required, which are the base for our calculation, for PERT, for CPM, unless and until we know the content meaning of each and every term, we will not be in a position to understand the content. Therefore, what we'll do, we'll stop today's lecture at this point of time, and I will start further analysis of network model from this slide in my next lecture. So here I am ending today's lecture. For the time being, you study whatever is given to you as a form of understanding the basic concept of PERT and CPM.